Okay, let's go ahead and get started with our example of creating this parametric stadium. And in the first step, what we're going to be basically doing is creating a lot of placement geometry. We're going to be creating some geometry for the stadium shell. We're going to do that by creating a series of different arcs. And to create those arcs, we're going to go through a number of steps. We'll set up a coordinate system, which is really just the origin for those different arcs, and the z-axis indicating really the center point about which those arcs should be drawn around. We'll create a list of the arc heights. We'll create a list of the arc radii. Okay, and then from that, we're going to define some arcs using a starting angle and an ending angle in degrees for each of those different arcs. So it's going to all start with basically creating a list of the arc center points. We're going to do that by aggregating together some points around the origin and then using the list of the arc heights to give us the arc center points. And then we'll create the arcs themselves using arc by center, point, radius, and angle when we feed it. The list of the center points, the list of the radii, the start angle, the end angle, and the normal for creating those arcs. That'll give us just a bunch of different arcs around the origin. Next up, we're going to create, to specify some truss placement parameters. Here we're just going to specify the number of trusses, use the family type truss, and we're going to specify whether we should regenerate the trusses in Revit. The idea is for a complicated structure like this, you don't necessarily want to regenerate all the geometry every time you run the graph. So we're going to put in a little code block, which is going to give us the ability to put in a 0 if we don't want to regenerate those, or a 1 if we do want to regenerate those. So that's a kind of a common structure to control the flow of the logic. We're going to specify some facade placement parameters too. So again, these are parameters that will be applied to those different arcs and curves we're creating. We'll have the number of panel columns, the number of panel rows in each column. So that's the number of panels stacked up within each column. We'll use the family types panel. And then finally, again, we'll put in that little switch to go through and control whether we want to regenerate the panels in Revit right now. Now, the seating risers is a little more complicated. It's similar to doing the arcs, but we have to sort of worry about, every riser has a height and has an increase in the radius associated with it. So we again start with specifying an origin for that system. We set the riser geometry parameters, so just basically what the initial radius is, how high it'll rise with each step, and how much the radius will increase. We'll call that the riser tread depth with each step and the total number of risers. So it's going to be a bunch of different arcs that are going to go through and model those risers. We'll create a sequence of the different radii and the different heights, basically going from the initial one plus an increment for the number of risers we want to create. So we have a series of heights starting at the initial height, then incrementing up. We'll also have the initial radius and we'll increment up again. So we have a couple different code blocks to help us kind of create that series of different height values and radius values. Finally, we're going to go through and create those riser arcs, again using the point by coordinates to create some center points. And then we'll say arc by center point, radius and angle to create those arcs. So that's all just a bunch of geometry for placing the components. So let's go ahead and take a look at what that all looks like. So here we are over in Revit and Dynamo. Let me go ahead and just start by clearing out all this. Oops, go a little bit further. Maybe third time's the charm. There we go. Delete all that. So we can clear our palette. You can sort of see the underlying curves defined by all this geometry when we regenerate it. We'll go through and recreate all that. So it all starts with basically setting up our coordinate system. Okay, that's going to be just 0, 0 as the center point of the arcs with a z vector, kind of pointing straight up. So let's start defining these different curves. Okay, we're going to start with the arc height being 0 and some different heights for the different arcs above that. And again, these are all on sliders, so we can adjust that. But we're going to basically take what? As our center point for the arcs, the x and y values, so the 0, 0, and then this series of different heights. That's going to create a bunch of different center points. Let's go ahead and just run that so far. Okay, you can sort of see there they are. Not too exciting so far. We're going to have a list of the 4 different radii, and we have a start angle and an ending angle. Let's put those all together. So basically, we're going to have our 4 different center points. We're going to have our little list of the different radii. Okay, and that should go through and create a series of 4 arcs. Let's give it a try. Super. So you can sort of see this will respond to whatever we specify as the angle. And we can go through and adjust the heights of the different arcs, the radiuses of the different arcs. Great. Next up, just in terms of specifying the trusses and the panels, right now we're not doing very much. We're just actually specifying some parameters. So we're going to have 6 trusses. We're going to divide this curve into, with 7 points to create the 6 different trusses. I take that back. 6 points to create the 6 different trusses using the truss family. And we'll use this flag right here, either entering 1 or 0 to specify whether to generate them. Similarly for the panels, we're going to specify the number of columns. That doesn't have to be the same as the number of trusses. We can kind of choose whether we want that to line up or be an increment of that, and the number of panels in each column. Again, we have a family type parameter, and we said that we want to generate that. Okay, for defining the seating riser geometry, this gets a little more complicated. Again, we're going to create a series of different arcs to do that, but let's take a look at this. It all starts with this notion that we have an origin, and I'm going to basically sort of have the risers around the same origin as the stadium shell, only we're going to raise it up about 5 feet. Okay, then we're going to have this series of height sequences, and it starts with this whole notion of there's the initial height of 5. We basically have a number of risers and the riser height. Okay, and if we put those all together, we'll get a sequence of different heights. Let's just go ahead and run that so far. So the heights are 5, 6.5, 8, and 9.5 because we're basically having a riser height of 1.5 and we're doing it for 4 risers. Similarly for the radiuses, we want to go through and say that there's an initial radius of 10. There are going to be a number of these different points, and the riser tread depth is 2, so it's going to increment by 2 feet for every riser we create. So there we have 10, 12, 14, 16. You can sort of see them all pretty much lying down there, almost on the floor. They're at kind of 5 right now. Let's go through and put the height sequence in here. Actually, it's 0 right now. So as we put the height sequence in there and we have the point by coordinates, we will have a series of different points which are indicating the heights. They're all down here right now. And then finally, we'll connect these all together. So we have the center points, we have the series of radiuses, we have the start angle, the end angle. We are good. You can sort of see now our arcs are sort of following those points. Looking good. Now, what do we have here? It says riser placement parameters. That's going to be in terms of how many points we're needing to go through and place things. Now, for the riser adaptive component, we have 5 placement points on that. That's why we're choosing 5 here, and we'll have that turned on and off. Super. So we now have the underlying geometry of the stadium, and we'll think about how we can then start subdividing those curves up to go through and start placing the adaptive components.